Hello, this is Ryan Zhang from APAC service team. So what I'm going to do is do a demo to show you the great feature, latest feature of karpenter, which is be able to auto-scaling rosa work node. Let's start. So before I jump into the demo and we'll show you the workflow, it's pretty straightforward. But first, why? Why customer are interested into this feature and why some customer would interesting to this feature. So basically, our OpenShift have traditionally have a cluster autoscaler feature to allow customer to be able to auto-scaling the infrastructure. However, there is some pitfall for that, and the cluster autoscaling it involves a lot of resource, like machine config pools, and also involves machine set API, etc. There are a couple of CRs you have to define on each CR, and it's not as flexible as a karpenter. So I will show you that a little bit more details later when I demo these karpenters. And so this is will be very useful for users on Rosa platform. But this is only for the managed service because it's the design is to interact with a cloud provider and can accelerating the infra provisioning. So let's look at this workflow. So basically I have a script to facilitate this. Basically, we're trickling some pod running, and then pods will be in pending status because it's requesting some resource which was not existing. And then Kubernetes scheduler will monitor this behavior, and then Karpenter controller will take over. And then it will interact with, in this case, AWS Cloud, and start to, before it start to provisioning, it will do a evaluating. So this evaluating is a key feature of this karpenter. So for customer, it's extremely simple. They just need to define this karpenter YAML file, and they can specify very flexible rules. You can specify instance type, multiple instance type. It's not like a machine set config, machine set, MCP configurations. So it's more flexible. You can specify multiple instance type. Also, you can specify the capacity type, like on demand, spot, and it will smartly evaluate and calculate how many you need it. And another great thing is it's very efficient. Basically, it's more simpler in the design, and it's for this part it will be just seconds or milliseconds delays when it's monitoring the situation. So the most of the time we're spending is just interact with AWS, with the cloud APIs. And then you can see for the step number 5, and then it start provisioning, and then after it's provisioning, it's automatic serving those pods. So the whole process is very efficient and much faster than the traditional cluster autoscaler. Second, the operation is extremely simple for user, and the user can save a lot of cost because they can specify based on their needs. They can specify different type of nodes, either GPUs or some chip nodes, and yeah, that's the main feature of that. Let's look at the demo itself. Okay, so first I'll show you. I prepared this deployment YAML file. So you can see I specify the carpenter label. So when it will looking at the like a node selector, this type of node. Of course, I don't have that node. So there is a concept called a node pools. So node pool is kind of a pools to supporting your workload. You can specify a lot of node pools per your need. And in current situation, it's a 0. So there's no demands, no nodes needed. Let's start the deploy. So after I triggering the deploy is start to deploy this inflate deployment. I have to mention that in this example, I by intention I specify quite a big resource to demonstrate the fast node provisioning, and let's start monitor some behavior running behind. For example, I can monitoring the namespace for the pod. It's in pending status. It's already 30 seconds, and then I'm going to look at the node provisioning. So it's already started, but so far it will take a few minutes to get a response for the AWS cloud, because you already see this node pool has already updated like 4 nodes. By calculation, this inflate parts will require 4 nodes. And then we just need to wait. I will pause this a little bit to save your time for watching this and come back later. Okay, now you can see on the left side, AWS has a response and AWS Cloud API has response. So you can see those node has been provisioning, but it's still in the not ready status. It's it will I expecting it will be soon. Will be ready soon. For this case, this M6 type of AWS node take 2 minutes to provisioning, and then they will take additional some time, 1 minute or more, to be able to make this node join the OpenShift cluster. As you can see, now it's already running. It's pretty fast compared to the original cluster autoscale, I would say. Okay, so basically this is the demo. What I'm going to do is show you how this efficient to be scaled down. For example, if you're running an AI workload or just one-time task, it's very expensive nodes, and you are expecting it will not running if nobody use it. And then I just kill this pod, and then it will just scale down. Okay, as you can see, after a few minutes, this node has been scaled down to 0. So yeah, that's all. Conclude everything I want to show in this demo. Thanks for watching this. I'm going to stop this recording.